Welcome back, everyone. Today we are going to kind of wrap up our solving quadratics unit by taking a look at all of the methods that we've learned and seeing how certain methods can be faster or more efficient for certain equations. So we're going to identify how we can choose which method to use when we're given a quadratic and asked to solve. Let's start off by just reviewing the different methods that we have. So one method that we went over was solving by undoing or taking square roots. For example, if you have x squared equals 4, you can just take the square root of both sides and find that x is plus or minus 2. We also talked about solving by factoring and then using the zero product property. Another method we went over was completing the square. And we used the area model to see where the steps that we go through come from. And then finally, our last method we went over was the quadratic formula. So what we'll do right now is go through kind of a checklist or a flowchart of what to look for when you're given a quadratic equation and how certain information about the equation can help you decide what method to use. So for example, to start off, if you're given a quadratic equation ax squared plus bx plus c, you can start off by looking at the b value. If there's no b value, so if b equals 0, in other words, there's no x in the equation, then we can solve by undoing. So we can move the c value over to the other side and then divide by a and then take the square root of both sides. So if there's no b value or there's no x value, b is 0, we can solve by undoing. Number 2 is assuming there is a b value. Next thing we want to check is if the leading coefficient, in other words, a, so if the leading coefficient is not 1, so a is not equal to 1, we want to check to see if there's common factors. And if there is a common factor between all three of the terms we're looking at, we want to factor that out. What that'll do is it'll make the numbers we're working with easier. They're going to become smaller numbers. So the work that we have to do, whatever method we choose from now on, is going to be less work. So we want to check and see if there are any common factors. Check if common factors. Okay, so if there are common factors, we can rewrite it by factoring up that common factor. The next thing we want to look at is if either a equals 1, and sometimes that's after factoring, or after looking at common factors. So if either you start with an a value of 1, or after taking out common factors, you end up with an a value of 1, the next thing you want to check for is factoring. And if a is 1, it's going to be pretty easy to check for factoring. We're just looking for factors of c that add up to b. So check for factoring. So you could go through all of the different factors of c, check and see if any of them add up to b. Sometimes it'll take a while depending on how many factors we have for c. But generally, I would recommend checking for factoring in this case. If you check it and we can't factor, if a equals 1 and we can't factor, and we could check for factoring if a is not equal to 1 too, also. It just means we're looking for factors of a times c that add up to b, so it might be a little bit more work. If a equals 1 and we can't factor, then at that point, I would recommend completing the square. And one note is completing the square is going to be easier, usually easier, if b is even. And that's because we're taking b, dividing it by 2, and squaring it. So if b is odd, like 3, we would get 1.5 squared, which is 2.25. So you'll be working with some decimals if it's odd. So it's fine if it's odd, but it's going to be easier if our b-value is even. Finally, number 5, if a is not equal to 1, so either you start off with an a value not equal to 1 and there's no common factors, or if after taking out common factors, you still have an a value that's not 1. At that point, you could check for factoring, but I would recommend using the quadratic formula at this point. So at this point, with an a value not equal to 1, the quadratic formula is usually going to be easier, especially if there's no common factors to make it 1. So a couple of notes. We can always use completing the square. Or the quadratic formula. For any quadratic. So no matter what quadratic we're given and asked to solve, we can always use completing the square or the quadratic formula. The reason why we go through this flowchart or have these recommendations is because although we could always use it, sometimes it takes more work and or is more difficult. Than other methods. So what this means is it could end up being more work for you if you don't factor it first. It might be easier to factor first. Or there's also, if it takes more steps, there are more opportunities to make mistakes. So there are more places where you could go wrong or make a mistake and then end up with the wrong answer. Just because the quadratic formula, for example, there's a lot of calculations you have to go through in order to simplify it. Okay, so we've talked about kind of like a flow chart, looking at some things we should check. What we'll do next is, in this video, we'll take a look at a quadratic. I'm going to show solving this quadratic using a few different methods, and that should hopefully make it a little bit more clear how some methods can be faster and easier than others. Okay, so here we're looking at 2x squared plus 20x plus 42 equals 0. In this case, we can't solve by undoing because we have an x term in there, so we have a b value that's not 0. What we'll look at first then is factoring. So our second step before was checking to see if there's any common factors. In this case, we do have a common factor between 2, 20, and 42. These can all be divided by 2. So we can rewrite this quadratic as 2 times x squared plus 10x plus 21 equals 0. And what we can do now is, because we have 0 on the right side, we could divide both sides by 2. And then the quadratic that we're working with becomes simpler. So it's easier, much easier to work with this quadratic than the first one. For example, here we have a leading coefficient of 1. So now we just have to find 2 factors of 21 that add to 10. So those 2 factors would be, so 21 and 1 don't work. 7 and 3 are 2 other factors. And we know that 7 plus 3 equals 10. So 7 and 3 are the 2 factors we're looking at. So we could set up the area model. X squared, 7x, 3x, and 21. And then we could look at finishing up the puzzle. X times 7 equals 7x. X times 3 equals 3x. And then the 2 factors we end up with are, so here to here, x plus 7 times x plus 3 equals 0. Okay, so now we just have to use the 0 product property. X plus 7 equals 0, or x plus 3 equals 0. And by subtracting 7, subtracting 3, we get x equals negative 7, or x equals -3. Okay, so here in this case, factoring is probably going to be the easiest or the simplest method to use. And that's why looking back, factoring is towards the top. It's in our second step, because if we can factor, especially if the leading coefficient is 1, it's usually going to be a lot faster and require fewer steps than our other methods. Okay, so x equals -7 or -3. The next method I want to look at is completing the square. So we'll start off the same way by looking at common factors. We can start by rewriting it and factoring out 2. And this way we end up with a quadratic that has a leading coefficient of 1. In order to complete the square, we need this leading coefficient to be 1. Okay, so we're looking at completing the square. Our goal is to end up with 5 divided by 2 squared. So we're taking b, dividing it by 2, and squaring it. And that's the value we want to end up with in that constant place. So 5 divided by 2 is 2.5. Or sorry, not 5. It should be 10 divided by 2. I was thinking ahead. 10 divided by 2 squared. 10 divided by 2 gives us 5, and then we take 5 and square it. So 25 is our goal in this case. So we want 25 in this spot. So what I'll do right now is I'm just going to think about 21. So 21, we need to add 4 to get to 25. So let's add 4 to both sides. And this is helpful because we can now rewrite this left side as a perfect square. We have x plus 5 squared equals 4. Now we can solve by undoing, so taking the square root of both sides. X plus 5 equals, keeping in mind we have plus or minus square root of 4. So plus or minus 2. And then finally, we'll split this up into our 2 signs, positive 2 and negative 2. So x plus 5 equals positive 2, or x plus 5 equals negative 2. And then finally, we can subtract 5 from both sides. So x equals -3, or x equals -7. So notice we end up with the same solutions we got up here, factoring -7 or -3. However, it looks like it was a little bit more work in the end, especially this step, finding out our goal, just calculating that. So that's completing the square for this example. So we can always use completing the square. In this case, it was a little bit more work. Finally, we'll take a look at the quadratic formula. So again, we could start by rewriting it as, by factoring out that 2, quadratic formula. So 2 times x squared plus 10x plus 21 equals 0. Divide both sides by 2, x squared plus 10x plus 21 equals 0. And then we can go ahead and identify our a, b, and c values. A is 1, b is 10, c is 21. And then plug those into our quadratic formula. So x equals -b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Okay, so what we'll do next is simplify. Let's start off by simplifying inside of our square root. So here we get 100 minus 4 times 21 is 84, all over 2. So -10 plus or minus the square root of 16 over 2. -10 plus or minus 4, square root of 16 is 4, over 2. And then finally, we'll split it up into our 2 situations, or 2 signs. X equals -10 plus 4 over 2, or x equals -10 minus 4 over 2. And finally, we end up with x equals negative 10 plus 4 is negative 6, negative 6 over 2 is negative 3, or negative 10 minus 4 is negative 14, negative 14 over 2 is negative 7. So again, we end up with these same solutions no matter what method we use. We'll end up with the same solutions to our quadratic. However, here there were a few more calculations that we had to make compared to completing the square or especially factoring. So we didn't have to do any squaring and factoring, for example. So here we use 3 different methods to solve this equation. Next, I want to take a look at what happens if we don't factor out this 2 first for the quadratic formula. All right, so here I put up on the screen, without going through all of the steps, what the quadratic formula would look like if we didn't factor out that 2 at first. So notice on the left here, a is 2, b is 20, c is 42. We end up with the same solutions, but the work that we have to do in the quadratic formula is a little bit more complicated. So the numbers we're working with are a lot larger. For example, here we're looking at 400 inside of our square root minus 336. And even these numbers at the very end, the negative 20 and the 8, are a little bit larger. So when we are working with these larger numbers, it is a little bit easier to make mistakes. So compare that to before. Here, when we factored out that 2, we were working with smaller numbers, easier to work with numbers inside of our square root and inside of our entire equation. So that's why I always recommend checking to see if there's any common factors first, because if we can change our equation to have smaller numbers, then it's going to be easier to work with those numbers. Okay, so in this video, we went over a flowchart of how to choose a method for solving quadratics. And then we went through a few examples of solving a single quadratic using a few different methods.